Hi friends, in this video we are going to work on how to import and export the material property in Ansys workbench. This is the window shows that Ansys workbench 2024 academic version. It's called student version. You can easily download in your Ansys website. Right? Let me start with basic static structural analysis. Yeah. This is the static structural. Any analysis, if you go static structural, thermal, any analysis, if you go, first property is engineering data. There only we are going to import and export the material. Please click engineering data. Okay. You can add the materials, right? First, I am going to create new material, right? Already we have a structural steel. If you wanted to explore, lot of materials are available in Ansys for engineering data. Go to engineering data source. You can check a lot of materials will be available, structural steel and air. If you go to engineering data source in upper words, you have a general materials. In general materials, you have a stainless steel, structural steel, titanium alloy, or different magnesium alloy. Every alloys are being defined in this engineering data source. Now we are going to create a new engineering data, which has been if you have done new research or any material property you wanted to include for your own mechanical property should be included. Then you have to go for engineering new creation of new engineering material. Okay. This is the engineering data source. After such as if you wanted to create new things, if I have taken a static structural steel, here you have a mechanical property like density, isotropy, elasticity, Young's modulus, and Poisson ratio. Every property is being defined in here, which is already been incorporated in ANSYS, right? That is a property we are included, right? Today we are going to create new material, right? I have given the name as SDK is one of the material I am giving it, right? I wanted to assign the SDK for material property. What are the material property I wanted to assign? Example, I wanted to assume physical property first. I have given a density. Okay, after density, in this density, I wanted to give the value of density. Example, I am giving 2.3. Right here, there will be unit kg per meter cube. If you wanted to change, you can change the unit. Go to units, SI units, and metric units. You can whatever you want, you can change it. I am giving SI units, so that 2.3 is my density I have given, right? In between, I wanted to have another material property. Instead of density, I wanted to have another material property. Next, I wanted to give the isotropy elastic property. I have given a linear elastic. I will take a isotropy elastic where I can give the Young's modulus and Poisson ratio, right? I am giving Young's modulus is 210 e power 3. I am giving it. This is on megapascal. I am giving it. Poisson ratio I am giving 0.3. Okay. The bulk modulus and shear modulus will be calculated by automatically by because of the relation of E to Young's E to bulk modulus E to G and E to K. The relationship, based on the relationship, this bulk modulus will be already created. This SDK material property is created where you will have a previously you will have a symbol to denote that you have to enter the values. Now you are not having any things, which is mean that SDK the file is being created, right? I wanted to save this material property where I wanted to use for any further research, further work. I wanted to use the same material property. I can go for SDK file, export engineering data, where you can go to file and export engineering data. Click where I can show in the desktop. I am giving the file name as SDK. SDK is the material property I was assigned. Save. Here you can go to desktop. You can see that the SDK material property is created. This is where we are able to create the material property by own, right? This structural steel is already existing property which is in Ansys. where I can take this existing property and I can use it. If you wanted to create new property, I can use for SDK, right? If you wanted to give a hyperelastic property, plasticity, creep, life, fatigue life, if you wanted to give a fatigue data, all the data can be incorporated by this method. Now I am going to import the engineering data, right? I am going to import the engineering data. Initially, I am going to delete this property. Okay. I am going to import the data of SDK file, right? File, import engineering data. Import engineering data. If you go here, you have a import engineering data. File and import engineering data where we already stored SDK file. You can select the SDK file and you can open it. See, now you can able to create the new property and that property saved already existing property saved file we are importing. This is way we are going to import and export the engineering data in Ansys workbench. Thank you for watching this. In this part, we are going to see how basic static structural analysis in the same Ansys Workbench 2024, right? This is a static structural part where engineering data sources are already available, whatever we have seen in before that how to import and export the material. Next step, we are going to do the static structural. First, geometry, right? For every analysis, first we have to import the geometry. This answers especially for finite element analysis tool. It can be incorporated design also, but in drawing the part in this answers is very complicated. So that we can have import the geometry, whatever you can draw in other software, other CAD software, and you can browse and you can import it, right? Browse, import geometry, browse. Today we are going to see one part of the crane, right? The one part of the crane we are going to analyze the part by static structural analysis. Open the file. Model. Next step is model. In model, what CAD model is converted into finite element model by doing a process called meshing. The meshing process and boundary condition and result will be evaluated in this model module. This is the model we are going to do the basic static structural analysis. Here the geometry have three parts. Now we have joined it in three parts. We are connected, we have assembled the model in the form of three parts, which is going to be this was the one part and this is the other part and this is the third part, right? Where which is used to be kept the bearing on this ball bearings on two ends, right? This is the model we are going to analyze. First, we have the material property. We have taken the material property as a static structural steel we have taken. Then we have a connection, right? Here we have a contact, right? This contact is very important. Whenever you have two different geometry you are assembled together, you wanted to find the stress distribution between the contact. Then only the stress or load will be distributed on one end to other end. So that we have a contact region. This is the two part of contact region. Here, if you go to contact, you have a different type of contact region. No separation, frictionless and rough and frictional contact, right? Whenever if you go for welding, other kind of operation, you can give bonded contact. Non-separation contacts will be given whenever there will be a permanent joint condition. We can give non-separation contact. Frictionless, you have a frictionless. If you are given a frictionless, there is no value input will be given for a coefficient of friction. If you take a difference between frictionless and friction, if you give friction, automatically the frictional coefficient they will ask. Coefficient of friction you have to enter. Now we are going to do bonded contact where which is the bearing is being contact between the housing. Housing will be contact with bearing. So that this is the contact step. Next step we are doing mesh, right? We are going to do mesh. Now we are giving a generate mesh. Generate mesh will be done and automatically based on the component, the mesh will be generated by the computer itself. We can generate the mesh. We can control the quality of mesh by using element size. If you wanted to give the element size, you can change the element size to 50 mm. If you change, it will be given in meter, so that we have to change the units, if you give the units will be in meter. I am giving an mm, so that I have given a 50 mm for this size. This is the size I wanted to mesh the size, right? The each element will be meshed in the size of 50 mm. Then I am giving generate mesh. Now the size has been changed. The size will be changed from 50 mm. Again, you can give 20 mm. Then you will feel comfortable. See, the size has been changed. Before it will be giving 50 mm. The size will be little bit, element size will be little bit larger. This is a little bit larger element size. I can reduce the element size by giving the mesh element size has been reduced to 20 mm. Now you can generate mesh. Now you can see feel the difference between the before and after reducing the size. This is a general process of doing a meshing. Now I am going to give the boundary condition. This is very important. I am going to give the boundary condition. Here I am going to completely arrest this part, right? All degrees of freedom, this part will be arrested. I am going to apply the load on these two ends where you have a vertical load will be acted on y direction. This is the y direction. Based on the y direction, the load will be acting downwards. First, I will fix the boundary condition. I have to select this region because this is the region I am going to fix. Right? Click it. Then yeah, you can have if you have a static structural insert, you have different conditions where you will have a fixed support. This is going to be fixed support. I am going to fix this entire region. The region is fixed. This is complete region. The complete region is fixed. This is all degrees of freedom. It will be fixed without any movement. Now I am going to apply the force on these two ends, right? This part, and this part. If you wanted to select all put together, you have to press control. By control, you have to select the entire object. Now you can go to static structural, insert force. Now we can give the force, right? Force can be given in three forms: vector, component, right? These are the two forms of the forces will be given. One was vector and another was component. You can give component because we are going to apply the force in y direction. We are going to apply in y direction. If you give the vector, it will be taken only one axis. If you are going for component, it will be taken x, y, z. I am going to apply the force in y direction. Wherever the yellow color denotes, you want to give the input. I am going to give the y value as 50 Newton. Or you can give 50 Newton. Now it is going to be upward side, right? So I wanted to give the force in downward side. So that I want to change the force downward so that minus 50 I am giving. Minus 50 I am giving it. This is the force where minus 50 will be given. It will be acting at downwards direction. We can see all the boundary conditions put together by clicking the static structural. Our first boundary condition is we are going to apply the fixed support. Second boundary condition is we are going to apply the force on both ends. Now we are going to solve the solution. Solution, solve. Now the solution has been done by you can see in the top portion. Now the solution is done. Whenever the green color tick mark will be shown, the solution has been done. Solution. Now I wanted to take the result. I wanted to take the result. I am taking the stress. If I wanted to take again, insert stress, volumetric stress, because all the direction I wanted to account the stress, equal volumetric stress. Evaluate all the results. Now you can see the results. This is where it tends to bend. This is the bend to bend whenever you apply the force, right? You can see the animation also. See how it is going to be. If you do proper contact only, the load will be transferred to this area. Then only you can able to find the clear picture on this condition. You can able to see the force will be generated. You can have a result, will you have a maximum and minimum stress which is going to be in the megapascal. You can able to visualize the correct picture by conducting this test. Now we are going to convert this part into an image file because we wanted to put into report or we wanted to do presentation. This part will be explained in the better way to convert this into an image file. You right click it, image to clipboard. Right click, you right click and you go for image to clipboard. If it is done, then you can go to any PowerPoint presentation. You can go, just you paste it. You can able to visualize the whatever the picture we have taken Ansys report will be generated in here. Again, if you wanted to give the boundary conditions, all the boundary condition put together, you wanted to make a presentation in the, you have to add in the pitch in PowerPoint presentation. You can go to image to clipboard, then you now you can see complete picture where you can have a boundary condition, what are the boundary condition we applied, fixed boundary condition and the forces. These are the things can be captured by image clipboard. Thank you for watching this video.